Okay, let's just start to solve this question. Hmm. I think it should be visible now, right? Okay, I've already solved this question using brute force approach. So I'll just explain the approach and the solution. First of all, let's just understand the question more deeply, more depth. Given a zero indexed array, nums of size n, find the maximum difference between nums of I and nums of j, where I is always smaller than j, and nums of I should always be smaller than nums of j. Okay, return the maximum difference if no such I and j exists. Return -1. Okay, so the question is, nums of I will always be smaller than nums of j. Suppose if the array is like this, array is somehow 5 comma 4 comma 3. So in this case we have to just return -1 because nums of I is not smaller than nums of j, right? Like nums of j is always greater than I. And also, what about the edge cases? Let's think if there is no elements in the array. So okay, the length should be minimum 2. So in that case is always going to be uh, up, like executed on its own. So the next case is, mm, let's just suppose, what is the next edge case? What about the negative integers? Okay, we don't have to think about that because the range is from 1 to 10 to the power 9. Okay, right. Okay, okay. So the first brute force approach that comes in my mind is, I'll just keep checking all the elements. If some element is smaller than the previous element, let's suppose we have the array some, let's take the example that we have been given 9 comma 4 comma 3 comma 2, right? So if I just uh, see this element, see, let's just think, um, we will get -1 in this example. Let's take this example, 7 comma 1 comma 5 comma 4. So here you can see 1 is smaller than 5 and 4. So what we'll do is, we'll keep a variable in which we'll just keep track of all the minimum elements that we have been getting after the first element, or the first element is the minimum element. In this example you can see, after that we'll just keep iterating through all the elements in the array. If that element is smaller than the previous element, let's suppose we have the element as, uh, here it is 11, and we'll get here 2 comma 7. Okay, so after, like the first in the first iteration, the minimum element that we are going to have is 7. After that we'll iterate through all the elements in the array, and we'll update the minimum element here, like 7 to 5. Okay, after that to 4, after that to 2, and we'll just keep iterating through all the elements. If we'll get something which is bigger than that element, bigger than the smaller element, we'll just update its value, and we'll just take the maximum difference between these two, or these two that we have been we have been computed previously. Let's just understand it in more depth using the code. Let's suppose I have the variable int minimum element is equal to nums of 0, and we also have maximum difference is nothing but, let's suppose we have int max. Okay, int min, because we are computing the minimum difference. Also we can have a variable as n, which is equal to nums dot size. So we'll iterate through all the elements. Index is equal to, we'll start from 1 because we have to compute the difference. index is equal to 1, index is smaller than n, index plus plus. Okay. Uh, if the nums of if the element is greater than if the element is greater than the minimum element, if it is greater than a minimum element, then we'll just compute the maximum difference. So maximum difference is equal to max of maximum difference comma the difference between these two elements, like the nums of index minus the minimum element. Okay. And if I'll get something which is if the minimum element, suppose we have like in this case 7 11, I'll get the maximum difference is 3. Okay, but if I'll get the minimum like element which is smaller than 7, we'll update the minimum element to 7. If it is the nums of index is smaller than the minimum element, we'll just update it. Minimum element is equal to the element nums of index, and we'll just return the answer. That's it. So if I'll just try run this code, suppose we have a array like this: 7 11 5 4 2 7. In the first iteration we have minimum element as 7. After that we'll compute the difference, we'll go through a loop. In the first iteration, 11 minus 7 will 11 is greater than 7, 11 minus 7 is 4. We'll get the value of maximum difference as 4. After that, in the second iteration, we'll get 5. So 5 is smaller than 7. So the minimum element will be updated as 5 from 7 to 5. After that, we'll have 4. It will again update as 4. Again, we have 2. So it will again update as 2. And now we have a element which is greater than the minimum element, that is 7. So we'll just decrease the value, like take the minimum difference. 7 minus 2 is equal to 5. The answer is equal to 5, right? So I think this looks fine. And for this one, I guess we can keep it as -1, because if it will not get the maximum difference, it will just return the -1 as the answer. Let's run this code. I think this will work fine. Okay. Yeah. Okay. Other than this, so the what is the time complexity of this code? So we are using some variables that is going to take off one time, and we are running the loop from index 1 to n. So the time complexity will be big O of n, and the space complexity is big O of 1. So it is the best solution that you can give. But let's just think of any other approach that we can solve this question using. Any other approach? Like one approach that comes to my mind is, there are many approaches that you can solve this question with, but one approach is a prefix sum or suffix sum, right? Like you will keep track of all the elements which is greater than like the previous element, or the like you can start from the ending index, and you will keep track of all the elements which is smaller than like which is greater than like, let's suppose I have this array, right? 7 1 5 4. Okay, so one approach is using prefix sum or suffix sum. Using suffix sum, you can say what I'll do is I'll keep track of all the elements which is greater from the ending index. Let's like understand it in more detail. Suppose we have this array 7154. I'll just keep track of all the elements from the ending index, right? So from the ending index, what is the maximum element? Let's just keep the last index as 0. After that, we find 4. So what is maximum, 4 or 0? So we'll get 4. After that, we'll again check from 4 and 5, which is greater than 5. We'll again check from 5 and 1, which is greater 5. And at the last, it is 7. So it is not going to be computed. So now what we'll do, we'll just check that this element is smaller than this element. If yes, we'll just update the value. We'll again check this element is smaller than this element. If yes, then we'll just compute the maximum difference. 5 minus 1 is nothing but 4. So the maximum difference is 4. We'll again check this element is smaller than this element. No. This element is smaller than this element. No. Let's again understand this using another example. Let's take example here. Okay. 1 comma 5 comma 2 comma 10. So I'll just keep a suffix array. See, 10 and 0. I'll just keep the first element as 0. After that, I'll just keep check 10 is greater than 0 or not. Yes, 10 is greater than 0. Again, I'll check. Yeah, again I'll check which is greater than which is greater, 2 or 10. So 10 is greater than 2. So I'll just keep 10 here. I again check 10 is greater or 5 is greater than 5. 10 is greater. So I'll just keep the element as 10. Okay. So this is how our suffix sum array will be going to look like. So if I just code it out, let's keep a not suffix sum, it's suffix array. So let's name it as suffix array, and I'll just uh, keep track of all the elements from ending index. So index is equal to n minus 1, which is int n is equal to nums dot size. Okay. So index is equal to n minus 1. Index is greater than equal to 0. Index plus plus. Okay. I'll just update the value of a suffix array as I'll just initialize its size n comma 0. Okay. And I'll keep an element which will keep track of all the maximum elements. Maximum elements is equal to 0. I'll first of all put the value of suffix array of index is nothing but maximum element. After that, what I'll do, I'll check which one is greater. Maximum element is equal to max of suffix or not suffix array. I'll just check off nums of index comma the maximum element. Okay, I'll do this and I'll keep adding the elements in the suffix array. Okay, so this is what our suffix array going to look like. Now after this step, we have built a suffix array and it is going to look like this. After that, what I'll do, I'll iterate through all the elements and I'll check is the suffix array's element is greater than the nums element or not. If yes, we'll just check the maximum difference. Again, updating the keeping the maximum difference is equal to -1, and iterating through all the elements. I index is equal to 0 to index is smaller than n, index plus plus. Okay, here it is going to be index minus minus, right? Yeah. So after this, we'll just check if the suffix array of index is greater than the nums of index. If this is the case, we just update the value. Maximum difference is equal to max of maximum difference, comma, uh, suffix array minus suffix array of index minus nums of index. We can do one more thing. We can just keep it in a variable in difference is equal to this, and yeah, this will make clean code clean. Yeah, if difference is uh, yeah, okay, just let it be. If suffix of index is greater than nums of index, right? Maximum difference is equal to maximum of maximum difference of suffix index minus nums of index. Yeah, it will just keep track of all the maximum differences among all the indexes. Okay, for index so 0. Yeah. So if I'll just return the difference, let's see. Let's just try run this code before submitting it. Int n is equal to nums of size. Okay, suffix array. Okay, suffix array of index is equal to maximum element. Okay, the first element is going to be 0, and after that we'll just run iterate through all the elements. The first and like second last element, which is 1520. Okay, and after going in the second loop for index is equal to 0, index is smaller than n, index plus plus, if suffix array of index, okay, suffix array, yeah, 10 is greater than 1, right? Maximum difference is equal to maximum of maximum difference comma suffix array of, let's see there is some compilation error or not. Okay, there is a compilation error where index is equal to minus n, index is greater than equal to 0, index minus minus. Okay, end. I have to just write end here, right? Okay. Maximum elements. Element, not elements. Maximum difference. Okay. Now is this going to work? Yeah, this works fine. So there was some compilation errors, but let's just compute the time complexity and space complexity of the solution. Yeah, it is going to be greater than the previous approach because in this approach we are using somewhat like suffix array, right? So we are going to have a extra time complexity of extra space complexity of O of big of n, and the time complexity is like we are computing through all the elements, so O of n here, and we are computing through all the elements, so O of n here. So yeah, the time complexity is going to be the same, which is O of n, but the space complexity will be going to O of n, which is greater than the previous approach. Let's just submit this code and see is this working fine or not. Yeah, it is working fine. So you can see the like in the previous solutions, like in this solution we have used nothing but just the variables, and the time complexity was O of n. So here the space complexity was bit lower than the space complexity that we are getting here, like you can see. Okay, yeah, so this works fine.